Cool. Let's start again. I think I had some network issues. I hope I'm live right now. Cool. So we are going over day 10, part 1. One way to achieve this is by pressing the last three buttons like this, once each. The third machine has a total of 6 indicator lights that needs to be configured correctly. Uh, Correct. Fewest press is required to correctly configure it is to this one and this one. So clearly order matters in which you perform these operations. Yes button press is required to correctly configure the indicator lights on all of the machines is this. Analyze each machine's indicator light diagram and button wiring schematics. What is the fewest button presses required to correctly configure the indicator lights on all of the machines? So each line is one individual problem. We need to solve all the problems and do we need to find the sum? What is expected? Okay. So this is the length. So I'm seeing 9 here. So most probably this length is at max 10. So that should be doable. We can store that in a bit mask. What else? Yeah, they are expecting to find out the answer for individual cases and give the final answer as the sum of the intermediate results. Cool. So let me think how we can achieve this. So one observation that I can think of is that this toggling is basically taking an XOR with a particular starting number. So if we can store this as a binary number, so this would be 00010, which is 2 in a binary format, and this would be a number which has 0th, second, third, and fourth bit set. So taking an XOR with any number will basically flip all the positions to the opposite ones. Correct. So that is fine. So over all the operations that we can perform, what we can do is we can create a graph of all possible transitions, and the answer would be the shortest path from the node with number 0 to the node with number whatever this is given in the input. So let's implement that. This is day 10. I'll use C++ for this. Cool. So this is the input format. Let's do one thing. Let's say we are getting inputs separated by spaces. So this first, this second, this third, and so on. So let's say this is input in. As long as we get the input, I need to check whether it starts with a square bracket, else if it starts with a round bracket, else if it starts with a curly bracket. So we need to ignore this for now. This input, what I need to do is, so let's see the length of this part would be in.size, and I will extract out only the inner part of it. So this should be the required mask, which should be in.substring from index 1, and the length should be subtracted by 2 because there are 2 characters at the start and end of that. Once I have this, so what I was thinking is, let's create all the inputs first. So let me also define one thing, or I can do this. So I can say that I have a pair of, or I can do this on the go. So let's just initially, this is the required num, let's set as 0, and required num becomes mask to integer. Let's write this function. This takes in the string, and this is the mask. We need to go over all the characters in the mask and only set those characters in mask if that particular character in that index is a hashtag. So result would be, so this bit should be set, which is like this. Okay, so once this is done, I need to find out these parts. So let's store this. Let's store the masks only. Let's say operations. And while we extract these out, we also have noticed that we don't have any double digits anywhere here. But most probably I'll write a logic so that that is taken care of. So this should, I need to reset this required num here initially, and also clear the ops vector. And whenever we receive an operation, first of all I will extract out the first and last character. So n is, let's get the n size, and this should be nums separated by commas. So this should be in dot substring from index 1 len minus 2, and I need to extract out all of these integers one by one. I will create the mask here itself. So let's say op is 0 for character ch in nums. If this is a digit, then I need to construct this particular number, add the new digit in the units place, and if it is not, let's do one thing, let's extract out everything from here so that once we reach the end of this particular substring, so I've removed the first character of this particular part, and once this is done, we can directly add this particular operation in, and op should be reset to 0. Okay, so let's do one thing. Let's check whether we have everything passed correctly. So this should be required num. So this should be main1. Let me get the input. Okay, looks like it is not correct. Let's see what we are doing wrong. And dot size required mask is the substring starting from index 1. Which is correct. Required num is also correct. What are we missing? If it is a digit, let's print everything. Okay, looks like we are able to parse it correctly, excluding the spaces. But okay, I think I need to clear this afterwards instead of before. Cool, let's try this again. Now let's just try one of the sample cases. So this is basically 0. One more thing that they have mentioned is we need to construct this from left to right side. So this is binary 2 raised to 0, 1 and 2. So 2 plus 4, which is 6, which should be the first input required number, correct? And let's also do where have we printed the vector? Yeah, so this is 3, but I've directly added 3 in the vector instead of this. What we had to do is I wanted to create a number out of this. So once this should not be a vector. I mean, this is correct, but it should have individual masks and not the numbers in this order. So if we look at the vector for any sample case, we would be having all these digits one after the other, 3 1 3 2 2 3, right? But we need to respect the groupings, and to do that what I can do is instead of this I'll and I don't think I need this. This should be ops.pushback op outside of the for loop, and this should construct a this will create a number of number. So let's name this in some better way, XOR masks. So XOR mask will have this particular bit as set. So this should be odd with this particular number, and this number should be set to 0, and XOR mask should be appended in the vector list. Now let's try this again. Doesn't seem correct. Should I just ignore the fact that I need to take care of other than single digit numbers? Let's do this in a simple way. So if this is a digit, this digit is like this, and I don't need this. What else? And this digit, XOR mask, captured by this. Okay, so what is the required number? So this is 8. So 2 raised to 3 is 8, which is correct. This is 0 based, and I've also taken this as 0 based, so that should be fine. This is 2 raised to 1 plus 2 raised to 3 should be 8 plus 2, 10. Looks good. Now let's move on to the problem. Instead of printing this, we need to solve this problem. So let's write a helper function for this. We have a required number and ops, and our final answer should be added to whatever is written by this. Let's print this. Part 1 answer is now let's write the solve function. So we have a target number and we have some operations that are given. Let's take in as a constant vector. Cool. And the way we apply these operations is, let me think of a better way to do this. Either we can start with 0 and end up at this target, or we can start with this target and work backwards. So one approach could be to use backtracking with pruning. Let's say we only prune until uh, 10 max depth, something like that. Or else what we can do, I think for part 2 it would be difficult to use any sort of backtracking approach. So I think I'll probably go with the optimized approach for this. Mm. So I was thinking of using a shortest path algorithm for this. Let me see if I have any template written for Dijkstra's algorithm. I'll probably use this, but I need to create a vector for this. Not vector, my bad. I intended to say graph. So we got this. Are we using NNM anywhere? I don't think so. So let's make this const int max nodes as 1005 because we have 10 raised to 2 raised to 10, which is no, my bad. They should be. Let's make it 11 and max nodes. This is fine. And to create the graph, we'll have a starting point of we can only traverse a certain number of nodes in this graph, and our starting point is basically 0. And if we arrive at a node for which we have already created edges, we need to ignore that. So I'll probably use DFS for this. Let's start with 0 and operations. Let's also have a visited. This is target. Let's use the same arguments here. If this is visited, let me use u, then return else. So this is the graph that we are creating, and for now it's fine that we can say, I mean, the cost of the edge is 1 always. So should I use a set here? And the format of this graph is basically edge. First is the adjacent node and second is the edge weight. So what we can do here is go over all the operations and g of u dot pushback. What should be the edge? So the node that we are moving to would be u XORed with operation. So this should be 2 and the weight should be 1. And we need to traverse. Let me mark this node as visited. Traverse the next node with operations. Okay, once this is done, we would have created a graph. Now I need to call Dijkstra from a particular starting point and a distance array. I think I also need to initialize it with a large value. Cool. So vector of int, let's say distances, max nodes, and let's define infinity. Infinity as 1e9. Infinity called extra. Starting point is 0 and distances. And the answer for this would be distances, minimum distance to reach target. Let's see if this works. I'll return the answer from here. I'm printing the answer for every case. Cool. And I'm also returning it from here. Okay, let's try this. Doesn't look correct. Let's debug. I'll be back in 2 minutes. Okay, I'm back. Let's debug where we are going wrong. So we got a very large answer for every case or just some of them. First of all, I will probably clean up this input. I'm printing everything. Okay. Most probably I also need to initialize this resistance for the starting node as 0. So 0 of 0 is 0. And let's say if we got the first two cases correct. So answer for the first is 2, which is correct. Second, my solution gave 1. Doesn't look correct, so let's try this again. Okay, still wrong. Let me print more values here. We got target as target. Okay, my bad. So this again should be set above the function where we are calling it. Hey Akash, I just saw your message. Maybe I also need to clear the graph after the first test case has been completed. So let's do one thing. Let's traverse the entire adjacency list. Let me do one thing. Instead of keeping this global, I'll probably create a new graph every time. So this should be g equals vector of pair of int comma int, and this has max nodes as the size. I don't think so. That should work. So I'll revert this probably. Let's do one thing. Let's clear all the nodes from this. GFI dot clear. Let's try again. And I also need to mark the visited as false. Visited of I is false. Okay, this made the answer worse because I need to call the DFS after the clearing is done, and distances is required here. Need to let me clean this up a little bit. So I'm clearing the adjacency list first, then I'm initializing the distances except the starting point, the distance for which is 0, then calling the DFS. This should construct the graph, and once the graph is constructed, it should be used in the shortest path algorithm computation. Okay, looks like we got the answer for all of the 3 cases, 2, 3, 2, and final sum as 7. Let's try the larger input. This is in into dot slash main on into. Answer is 447. Looks correct. Let's move on to part 2. Let me also commit this first. Need sample inputs and main function. Let's commit this. Solved D10 part 1 in C++. Okay, let's get back to part 2. All of the machines are starting to come online. Now it's time to worry about the voltage requirements. Each machine needs to be configured to exactly the specified voltage levels to function properly. Below the buttons on each machine is a big lever that you can use to switch the buttons from configuring the indicator lights to increasing the voltage level. Ignore the indicator light diagrams. What are indicator light diagrams? Okay, so in part 2 they want us to ignore this. In part 1 we ignore this input. In part 2 they are saying to ignore this. Cool. The machines each have a set of numeric counters tracking its voltage levels. One counter for voltage requirement. The counters are all initially set to 0. So voltage requirements like 3, 5, 4, 7 mean that the machine has 4 counters which are initially 0, and that the goal is to simultaneously configure the first counter to be 3, second to be 5, third to be 4, and fourth to be 7. Okay. The button wiring schematics are still relevant. In this new voltage configuration mode, each button now indicates which counter it affects. 0 means the first, 1 means the second, and so on. When you push a button, each listed counter is increased by 1. So button wiring schematic like this means that each time you push that button, the second and the fourth counter would each increase by 1. If the current voltage levels are these, pushing the button would change them. This and this should be incremented. Sorry, this. You can push each button as many times as you like. However, your finger is getting sore from all the button pushing, so you will need to determine the fewest total presses required to correctly configure each machine's voltage level counters to match the specified voltage requirements. Okay. So we initially have a large array of zeros. Let me copy this. So let me frame the problem correctly. So we have zeros, and these operations are basically adding 1 at their respective positions. So it could be 0, 2, 2, 3, something like this. And what do we need to arrive at? We need to arrive at this requirements. Configuring the first machine's counter requires a minimum of 10 button presses. One way to do this is by pressing 3 ones, and this is this. Okay, I think only thing that matters is how many times we need to use each of these um, buttons, because order doesn't matter, because everything will contribute the same in the final requirement. So what I was thinking is, let's see what is the input format. Okay, so these numbers are quite large, and how many steps do we have here? Let me get that from the input. I'll probably use Python for this. So let's read the lines. Open into in read mode. Read dot split and lines. Let's use the smaller input first. So for each of them, I need to find out how many opening brackets do we have. Those many operations would be present in the input. So let's see max of line dot count opening parenthesis for line in lines. 6. Let's also print them. Let's print this list. 6540. So this has 1, 2, 3, 4, 5, 6. Correct. Let's do the same for the larger input. And I want to get the maximum of this. Thirteen. So we have 13 unique operations. And for each of them, I need to decide how many number of times I need to use that particular operation. And the issue is these numbers are quite large. So it's possible that we have a single operation which increments one index, and that needs to be repeated how many number of times. What is the maximum number that we have here? Let's also do that. Let's see RG 2-digit numbers. Do we have any 3-digit numbers? Yes. Let's see for all the 3-digit numbers, what is the maximum value. So let's take this sort. 296 is the highest number in this, so 296 should be present here. So it's possible that, I mean, this discuss doesn't introduce that, but it would have index which needs to be incremented 296 number of times. So max number of times we need to perform a particular operation is upper limit on number of times a particular operation can be performed is 300. What else? Correctly configure the voltage level counters on all of the machines. These numbers are not that, the count of these numbers is not that high. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think this is again 10. So if I have to formalize the problem, so what I need to do is either I can treat it backwards, or backwards would be a better approach. So we have these, and each of these particular round bracket operations are decrementing, or let's say performing -1 on a given set of indices, and we need to find out minimum steps to perform to make all values from, let's say this list is a as 0, so all these should be converted to zeros, and so on. How do we do this? So we have at most let me paste the link for advent of code. So we have 9 sets of indices. So these are like a list which has multiple lists inside them, so on. And any set can be used at most 300 times. The issue is storing this particular value in a state. We can't possibly store this in a state. So what else is the alternative? Configuring the third machine's counter required a minimum of 11 button presses. One way to do this is by pressing this set of indices 5 times, this 5 times, and this once. I can possibly treat this as a graph problem again. Let's say we have this as the starting point, and applying any operation on this will give me another node. So let's say each node in the graph is a state of this array, and adding an operation, performing an operation creates a new node, or we move from one node to other, and it will definitely create a acyclic graph. That is correct. Because the indices would always, I mean, these values would always decrement if we are considering the reverse of the given problem. And we just need to find out, if we go breadth-wise, we just need to find out when we reach at a configuration which is 000. But I'm not quite sure of the time complexity for that. But I think I would like to try that approach. We start at this. Let me write down the approach. Start at this configuration and apply all operations. Let's say there are n operations. Then we will have n new nodes to start from, and we basically keep doing the same thing. But I just want to know if this will explode in time complexity, because starting from here, if we keep incrementing, if we keep applying operations, it will possibly have a large number of nodes created. But I don't see any other approach helpful here. Most probably this is a backtracking problem only. So these numbers, if I have to find out what is the product of them, this is this s dot split on comma map them to integers and import math dot product else. Okay, so this is still quite large. I mean, this is the number of unique states we can achieve, but I don't think all of those would be reachable. So let's try this approach only. So we don't need the graph, we don't need Dijkstra, DFS, we also don't need this. We need to ignore this part. So let's ignore this. Have these operations. And instead of storing XOR, what I can do is, I mean, it's fine, we can store that also. I need to extract these numbers. So for this, what I can do is vector of, let's say, string nums as in dot substring from index 1, and do the same thing that we were doing here. Vector of This is num string. This is nums character ch in num string. If the character is digit, I will add that particular digit in units position of num into 10 plus ch minus 0, else I need to append this in vector, initialize this to 0, and what else? So we have this and this bit masks. Let's also print this first. Okay, we got 354775 1272. Yeah, this is cool. Let's comment this, and here let's write a separate function solve and add the answer for this particular case as a return type, as a returned value from this function. So this takes in the nums and the operations. Let's write the solve function. Solve, yeah, vector of, this is the start, and vector of ends operations. So this should be a queue of vectors, and queue will have a starting value of this as long as the queue is not empty. I will keep performing the operations and discard the values that are not present in this. So initially the number of iteration is 0, and let's extract out the node which is queue.front and pop that particular element. Then I need to go over all the operations. I also need to increment the iterations by 1. And one more thing that I can do here is I don't think this is required here. I think I will do it at the end. And if check if this is a valid case. So I can simply check the sum of elements in this node dot begin, node dot end, start at 0. If the sum of since these are positive values, checking if all of them are 0 is same as checking the sum is 0. If the sum is 0, I can simply return the answer from here, which is the number of iterations that have been performed until now. And what else? So I need to go over. So this list will have how many nodes? Const int length is node dot size, and I will go over all the bits of this size in operation. If this bit is set, then I need to decrement this particular. I need to copy this vector first. So new node is vector created from node dot begin, node dot end, and new node of this particular index should be subtracted by 1. After this is done, I will get this, but I will only create this node if all the elements are greater than equals to 0. Let's check if any one of them is negative. Is negative int x in new node is negative is true if any one of them is less than 0. If this is not negative, then I will add this particular new node in the queue to be available for the next iteration. Okay, let me verify this once again. Incrementing, so let's call this iterations. Cool. So we start with the 0th iteration and the starting node. We check if all the elements in a particular node have become 0. Then that means that is the shortest path to reach or perform the target operations. Then we check in. This size will always stay the same. So what I can do is I can extract this out to here, and this is start. This is, let me clean this up a little bit. We have length. We check the first element in the queue, check if all the elements are 0, and let's not use 64-bit integers here. Already this will become too slow to process. For int I0, I'll probably use 64-bit for this. And for this as well. Cool. So we go over all the operations. This could be constant. We are creating a copy of the node in the new node, and we are going over every operation. For every operation, a new node would be created. In that new node, this particular, if the operation says to if that bit is set in the operation which we generated here, then the new node will have 1 minus the value that the earlier node had. If it is not negative, then we'll push it. Okay, let's try this. Cool. Let's see if this is fast enough. Are we in an infinite loop? I think so. What are we missing here? So this is correct. Nums is correct. Let's add some checkpoints. Let's also add some checkpoints in here. Is negative is false, and if any one of them becomes less than 0, it becomes true. If it's true, then we are not adding it in the queue again. We are also popping the element from the queue, so that should not be an issue again. Let me also print for what input it is taking too much time, or it's stuck in an infinite loop. So this is G++ main 2.cp run on in 1. Okay. Okay, so looks like it is stuck in this loop itself. Let's check if this node is getting created correctly. Is the assumption for a directed acyclic graph wrong here? Because this should not be creating the same nodes again and again. Let's add the condition for that as well. So let's say we have a set of vector of ends visited, or let's make it a map so that we can store the actual count of iterations to reach any particular state. This would be very heavy, but let's see if we at least arrive at some answer, or at least a valid answer for the sample test case. So if visited dot count node, we should continue from this. Otherwise, I should add the iterations required to reach this state. Okay, looks like the answer is wrong. Let's remove this. So print the answer. This. I mean, this should return something else. It should not return the number of iterations. And let's remove this iterations thing. Let's remove this and let's make this 64 underscore t. This should return set it off. Set it off. I think this should be required. Let's print visited count for this node while we are returning the answer. Visited of node. And we are also using iterations to save this value. Still not right. This is always 0 because this would not have been set if it was the final node that we are traversing. So like this is expected. I think the queue should also have what the distance are we at currently. That should also not be a problem actually. Let me write this in a simple format. So instead of queue, I'll use a vector and I'll replace this vector every time. So let's say pushback start, and I will simply replace this by the number of iterations that we are performing. So there is 0. Let's make this infinite loop plus plus, and inside this I will go over all the elements for auto node in this queue. This should happen inside the for loop. Okay. And we should also create a new queue after every iteration is complete. Let's name that new queue. Original queue should be replaced by this new queue. And we check if this node has all zeros. If that's the case, the answer is simply let's remove this visited for now. printing the iter, and let's also remove this. Comment this as well, and this should be added in new queue dot pushback. This is fine. What else? So this way, every time a set of nodes would be replaced by a one level deeper set of nodes. So let's try this. Again, we are stuck in a loop. This should not happen ideally. Let's print the contents X in this loop. Then looks like there are multiple duplicates in these. Let me try using set and check again. Got the answer as 33. Okay. I'm not sure why using set. I think we are not stuck in a loop, but there are like exponentially large number of nodes that are created each time. So we are traversing the same number of uh, same set of nodes multiple number of times. That could be one of the issue, I think. Let me just verify the individual answers as 10, 12, 11. Yeah, iter 10, 12, and 11. Most probably this will not work on the larger input, but let's try it. What was the command? /main into this is still not even processing the first test case. $43.89. I don't think this solution is efficient enough to solve this problem. Mhm. I don't think this will work. Let me think of something else. What else can I do here? So this is the target array, and these are the operations. The max element in this is like max value, let's say 300 for now. Each operation will decrement these set of indices from this array, and we need to find out what is the minimum set of operations to use to do that. And these are at most 10, and target array length is also restricted by 10. I can think of problem in a reverse manner. So let's say the target array is wants the 0th index to be reduced by 7. If I list down the operations like this, so first index should be decremented by 5, second by 12. So we want those operations in which let's only solve for 0th index. So let's say the array only was like this. Then the only operations that we could have used were this one, 0, 4, and 0, 1, 2. So once we decide this number, in this particular set of operations, we need to allocate numbers such that, so let's say we need to allocate x, y, and z. Set x plus y plus z is exactly 7, because these three operations will decrement the value at index 0 in total 7 times. So once this is decided, there is no greedy approach here, most probably. So once we have finally decided how many number of times a particular operation is to be used, after that a decision has been made for that particular operation. So for example, we have decided that we want to use this 25 times, then we can't uh, come back to it again and say that this should be 27, because we are solving uh, the answer one index at one index at a time for the target array. Okay, so 0, but again this could lead to so many number of combinations. X plus y plus z is 7. So worst case, this can be like, there could be 10 operations, each having the same index. So this could be x plus y plus 6, 10, and max value of any element in the array is 300. And I'm not sure how I can possibly go over all the combinations in this. I'll probably end this stream now and think on this problem. I'll try to solve this in the next stream. We couldn't solve much. We only could solve 9 and 10 part once only, which is expected because the difficulty is very high for these problems. Yeah, I think that should be it for today. you for watching. Bye bye.